Hi, this is section 7.8, properties of determinants. So it says if a matrix B is obtained from A by interchanging two rows, then the determinants are opposites. So if you interchange two rows or columns, then the determinant will just become negative of the original determinant. The second one says that if you multiply every element of one row or a column by some constant, then the determinant will just equal that constant times the original determinant. And the last one says that if you add k times any row, so if you multiply any row by a constant and you add it to a different row or column, then the determinant will just not change at all. It'll be the same determinant as the original one. And if two rows or columns are identical, then the determinant will be equal to 0. So it says here, without expanding, explain why the statement is true. Well, because there's a negative here, I'm led to believe that it's going to be because of this theorem, part A. So let's see if we can find two rows that have been interchanged, or columns. So it looks like the first and the third have been interchanged, and therefore that is why there is a negative. So I'm just going to say, by theorem, I'll just call it A. It was the first one. Yes, it was. By theorem A. Okay, this one, there's a 4 here, a constant, so I'm led to believe that it's probably going to be B because it says that the determinant is equal to the original determinant times the constant. In this case, it's going to be 4. So let's see if we can find where that constant is coming from. Well, if you multiply this row by 2, then you get this. And if you multiply this row by 2, you get this. So that's where the two 2's come from. There's one here, and there's one here, and clearly 2 times 2 is equal to 4. So that would be, by theorem B, okay. Find the determinant of the matrix after introducing zeros. So they say after introducing zeros. The reason why they want us to do that is to make our lives easier. So if we introduce a 0 here and a 0 here, then we can just go off of this one column, and then we only have one entry to worry about. So let's do that. Let's introduce this 0 first. So first thing I'm going to do is I'm going to multiply row 3 by positive 2 and add that to row 2, and that's going to equal my new row 2. So let's recreate this matrix. Okay, so this one will become a 0. And then this will be 6 plus 0 is 6. This will become negative 2 plus 1 is negative 1. All right, and now let's make this a 0. And we're going to do that by multiplying negative 3 times row 3 plus row 1 will equal row 1. So that would make this a 0. And this would be negative 9 plus 1 is negative 8. This would be positive 3 plus 0 is 3. Okay, so remember, by doing what I just did, I'm multiplying and adding to a different row. That does not change the determinant because that's what part C says. It says that the determinant will remain the same. So the determinant of this will equal the determinant of that. So that's why we were doing that. Okay, now let's find the determinant, and we're going to go off of column 1. So the only entry we have to worry about is the last one, which is 1. This is the only one we have to worry about. All right, so now there's your 1. We cross out that column and that row. And we're left with the 2 by 2 matrix. And if you find the determinant of that, that's going to be 8 minus 18. 8 minus 18 is negative 10. And finally, negative 1 to the I plus j power. And the I and the j of this entry here would be row 3, column 1, so 3 plus 1. Which is 4. That's an even number, so that's positive 1. So that's going to be negative 10 is the final answer. All right. So that's what introducing zeros does. It makes finding the determinant much easier. So let's do the same exact thing for this one. So I'm going to do the same thing. I'm going to introduce a 0 here and here. That way we can work off of column number 1. So step number 1 is let's multiply row 4 by positive 2 and add that to row 2, and that will equal my new row 2. So let's recreate this matrix. Okay, it doesn't like when I do that. Okay, so here we go. So if we do that first transformation, row transformation, this will become a 0. All right, the next one will be that would become positive 4 plus 0 is 4. This would become 0 plus 1 is 1. This will become negative 6 plus 4 is negative 2. All right, and then the last one we need to make a 0 is this one. So we're going to multiply row 4 by 3. Add that to row 1, and that's going to equal my new row 1. All right, so that would be negative 3 plus 3 is 0. That would be negative 6 plus 1 is negative 5. That would be 0 plus negative 2 is negative 2. And negative 9 plus 2 is negative 7. All right, now we're going to work off of this column. So the determinant, I'm going to call this matrix A. The determinant of matrix A is going to be negative 1, since that's our only entry. And we're going to have to cross out that row and column. So now we have a 3 by 3 matrix. So you can introduce 0, 0. I'm just going to use my calculator to find the determinant, and that's something I can also show you how to do. So for now, let me just go ahead and enter that into my calculator. All right, I'm getting negative 88 for the determinant of this 3 by 3, negative 88. And now don't forget the negative 1 to the I plus j power. Well, since we're referring to this entry, negative 1, that would be row 4, column 1, so 4 plus 1, which is 5. That's an odd number, so that would be negative 1. So you have a negative times a negative times a negative is a negative, and so our final answer is negative 88. Okay, let's look at the last topic in this section, which is Cramer's rule for two variables. So if you have a system of equations, two variables, so there's an alternative way to solve this system, and it's called Cramer's rule. So it involves matrices. So the matrix D is going to just be the coefficient matrix. D sub x is going to be, you're going to replace the x column with the constants, and the y column stays the same. And then for D sub y, you're going to replace the y column with the constants, and the x column stays the same. And then the solution is going to be the determinant of this matrix divided by this, and the y is the determinant of the D sub y over the determinant of the D matrix. So let's apply this rule. So let's first set up our three matrices. D is going to be 2, -3, 5, 7. D sub x is going to be, this is where you replace the x column with the constants, and the y column stays the same. And then finally we have the D sub y, and that's where we replace the y column with the constants, and the x column stays the same. All right, now let's find the determinant of these three matrices. So the determinant will be 14 minus -15. That's double negative. That's plus. 14 plus 15 is 29. D sub x, the determinant is going to be -28 minus -3. That's double negative again, so that's plus 3. So -28 plus 3 is -25. And then the last one is going to be 2 minus -20. Double negative is plus. So 2 plus 20 is 22. And so the final answer is going to be x is equal to d sub x over d, which is -25 over 29. And y is going to equal to d sub y over d. And that is our final answer. That concludes the section.